Welcome, AP Statistics, to Chapter 7. Can you believe we've already made it this far? We're going to start with Section 7.1 on what is a sampling distribution. Before we get started, we are going to review two terms that we covered, I believe, in Chapter 4, Chapter 5. Population and sample. So when you're reading through a problem, it's important to understand the difference between the two and be able to identify the two. So let's start with example A here. An archaeological dig turns up large numbers of pottery shards, broken stone tools, and other artifacts. Students working on the project classify each artifact and assign it a number. The counts in different categories are important for understanding the site, so the project director chooses 2% of the artifacts at random and checks the students' work. All right. This is one of those where I actually like to work backwards. I like to figure out what the sample is first because that gives me some clues about what they're looking for the population. So I can tell that my sample is 2% of the artifacts. So I'm going to talk about the sample first. Sample 2% of artifacts. So we take samples from our population. That helps me define what the population was. So if I think about where did these artifacts come from? So is it all the artifacts on the planet that they're taking 2% of? No, it's all of the artifacts at this particular dig. So that's what I'm going to write. Artifacts at this dig site. That's our population. If you were to just say artifacts, you would be wrong because that is not specific enough as to the artifacts that we're currently checking. So where did that 2% come from? Was it 2% of every artifact ever found ever? Or is it specific? So be careful when talking about your population. That's a common error. So here's what I'd like you to do. I'd like you guys to read through B and let me see if you can figure out what the population and the sample is for this next problem. So finding the population was probably easy for you, the 45,000 credit card purchasers. It was the sample that was a little more difficult in this problem. Was it the 1,000 people chosen, or was it the 137 people who actually returned the survey? So I did give you that hint in the prompt that it's what can you actually study? So what was your result? So the sample would be the 137 people surveyed, or people who returned the survey. So be careful with that. That's a really common issue as well, is being careful that it's what can you study? What do you actually know results about? That's your sample. So who was surveyed, the 1,000 people, but who can we use as a sample, the 137 that returned it. Now that we've reviewed populations and samples, that's what we're focusing on in Chapter 7. How do we take those samples and make sense of them and actually prove or disprove that things we suspect are true are true? Hypotheses, basically, for those scientists among us. Let's start with two more definitions. So we've got parameters and statistics. A parameter is a number that describes characteristics about the population. What's really nice about parameter, it starts with a P, as does population, so it's easy to remember which is which. Parameters go with population. Then the way we denote them is usually in their true form. So P is a population proportion. Mu we are already familiar with is our population mean. And if we've got standard deviation, that's usually sigma. So all of those symbols are used to describe our parameters, our basics about our population. Moving on to statistics. A statistic is a number that describes characteristics about the sample. Once again, you can see statistics starts with S, as does sample. I love it when those things happen. They don't happen very often, but parameters, population, statistics, sample. Really easy to remember the difference between the two. Our notation for these, our first one, if we're talking about proportions, I didn't write the word proportion before, so you might have missed it. The P stands for your population proportion. This notation, P hat, this is your sample proportion. And you're going to learn all about that in this chapter, what a sample proportion is. But basically, it's just saying blank % of our population seems to show this, or blank % of our sample seems to show this. So those are the types of things we're looking for. Mean, we're going to bring back X bar. We haven't seen this guy in a while. The difference between X bar and mu refers to your population. It's your actual true mean. X bar is the mean of your sample. Okay, so you want to keep those two different. Then the last one, on your calculator, usually they use S. That's your sample standard deviation. Sometimes you'll see S sub P hat or S sub X bar. That is not as important, as long as you got the S there. I'm also going to tell you quite honestly, on the AP exam, the two notations don't matter as much. If you're not sure, just be safe and put SD equals. It doesn't really matter as much for standard deviation. They really are picky, however, about using the correct notation for proportion or for the means. So be careful there. And you'll see lots of examples, so you'll see what I'm talking about here. All right, so this, of course, is standard deviation. Let's talk about sampling variability and look at types of distribution to wrap this video up. Sampling variability is simply the concept that as we take many samples, so if I survey 10 people today and I sample 10 different people later in the day, I shouldn't expect to get the same answer. And if I keep repeating this process over and over with different samples, I should not expect to get the same results with every sample. That's what sampling variability is. It's a measurement of how much a statistic can vary between repeated random sampling. Moving on to types of distribution. This is a simple concept, but it is a concept that students and people who take the AP exam get wrong all the time. They are super picky over your wording on the AP exam when it comes to this. Please make sure you use the correct wording here. So when we look at types of distribution, the first type of distribution is just your population. How is your population truly distributed? That is your population distribution. So what is the difference between the distribution of the population, the distribution of the sample, and the sampling distribution of a sampling statistic? All right. Most people don't get this one wrong. We look at our population, we know that, for example, the 50 people prefer 50% of everyone prefers blue and 50% of everyone prefers red. Who knows? But we're just looking at some population. I have no idea what it was, but it's actually 50-50. Now, when I take a sample from that population, the sample data will show hopefully something different. You might get 50-50, but on one sample, you might get, this one was 40%, 8 out of 20. This one was 55%, 11 out of 20. So two different samples. So this is a distribution of the sample. So this is the results of a 20 sample, size 20 sample that was taken. This is a different one. Okay, here's where the mistake occurs. The sampling distribution. If I take these two and many others, it looks like maybe there's 100 or more in this one. If I take all of these results and plot those proportions as on a dot plot, that is a sampling distribution. This is a distribution of the sample. This is a sampling distribution. You can see where students make the mistake there. The words are so subtly different. Distribution of a sample, sampling distribution, taking all of your samples and looking at their distribution. So let me know if you have any questions there. I'd be happy to answer them. Definitely make yourself some notes down here so that you can remember what the difference between this and this are. Try to put that in your own words. That'll help you remember.